Welcome to our Spring 2022 Ultimaker Showcase event. We are really excited about the developments we are sharing with you today. I believe that what we are announcing today is a true game changer for users of our technology. I'm pleased to have a few 3D printing experts across the design, architecture, and engineering industries share with us how our new developments impact their work. Today I'm excited to announce, firstly, the Ultimaker Metal FFF solution. We'll be talking with the metal 3D printing experts about how we have taken complex and expensive production processes and are making it much more accessible to more companies. Further, we are here to introduce the latest version of the world's most used 3D printing preparation software called Cura. It's a release that marks a major milestone in the history of Ultimaker Cura with a brand new slicing engine and other great new features. And my colleagues will show you more in a moment. But first, I want to take this moment to celebrate Cura, to celebrate the team here at Ultimaker that develops each release every day, our amazing community of contributors, and you, the many beta testers and users who send us feedback and suggestions. Because of this effort, millions of 3D prints begin life with Ultimaker Cura every month. I really love hearing customers talk about how 3D printing helps them with new developments and accelerates their new product introductions. Or even to learn how 3D printed tools and fixtures keep people safe in the factory, or even enhance the ergonomics of their factory workstations. I mean, who would intuitively connect 3D printing to the well-being of workers? Or even how 3D printed parts help production line changeovers happen so much faster than before. Who would have thought to connect 3D printing to improved machine utilization and even factory productivity? You know, the myriad of creative, inventive uses we learn about and the impactful stories we hear show how 3D printing can empower any individual or organization who wants to change their world in the biggest or the smallest way. We're talking about real, meaningful applications that improve people's lives and impact business results in a positive way. Our products are used by major brands around the world, but also by small and medium-sized businesses. But however impressive the cost and efficiency savings they can achieve, Ultimaker has always been about much more than this. We help to make 3D printing a possibility for everyone, for social, inclusive organizations who create 3D printed Braille learning or working tools, medics printing prosthetics and orthotics, schools who could equip the next generation with vital problem-solving and STEM skills. You know, we're about making 3D printing a real possibility for anyone who wants to turn an idea into a physical object in their home, garage, workshop, or factory. At Ultimaker, we're all about removing the complexity barriers of 3D printing and making it easy to use, more appliance-like, and if you will, intuitive. We are focused on enhancing quality, tolerances, and finesse of your prints, and to enable usage of a wider range of materials. And we put our efforts into making 3D printing faster. To get to a better end result, easier, quicker, and more consistently, a simple but challenging formula, one that we are passionate about. We consider today's showcase event a milestone in 3D printing because we will be sharing improvements to what new and existing printers will be capable of as of today. In fact, we are convinced of this step change, that even those who have looked at 3D printing in the past and concluded that it may not be ready for their use, that today it is time for them to look again. Many of you will recognize that until now, you had to make your design work for 3D printing. It's time to turn the table from designing for 3D printing to 3D printing for design. Solutions and applications focused, user focused. In a moment, you will see some of the Ultimaker team share what we've been developing and share the benefits to new and existing users of 3D printing, opening up even more uses and applications. We are also delighted and honored to be joined by the award-winning lighting, accessory, and furniture designer, Tom Dixon, engineer and 3D tech consultant, Steve Cox, and 3D modeling expert architect, Carlos Castillo. They've had early access to the new products we're showcasing today and are ready to inspire you with their learnings and applications. So with so much exciting news to present and such inspiring speakers ready to share their thoughts, I think it's time to get started. I hope you enjoy the showcase.
Ultimaker Cura is the most used 3D slicing software in the world. With over 4 million files sliced every week and over 500 million total files sliced, we've helped countless companies, institutions, and individuals realize the magic of 3D printing. Version after version, Ultimaker Cura has continually advanced, adding new features and improvements that have helped it stay on the cutting edge of 3D printing technology, all of which has brought us to now. Get ready for a breakthrough in 3D printing with Ultimaker Cura5. Introducing a revolutionary new slicing engine that enables you to print finer details than ever before. Join the thousands of people using Ultimaker Cura every day and discover a world of new possibilities.
Hello everybody, my name is Mariska Maas and I'm a business analyst for the Cura team. Almost everybody in the 3D printing world knows Ultimaker Cura. If you don't, Cura is a slicer that creates files that a 3D printer can understand. We call it a slicer because it divides a 3D model into a stack of flat layers. It's the bridge between your ideas and the physical part that you can touch. There's a reason why we have 4.7 million slices every week. For context, this means that every second more than 5 people around the world are using Cura to turn a 3D model into movements for a 3D printer. If you use the slice, it's easy to get a successful print the first time, no matter what printer you use. It's open and it's straightforward. After this live event, we're releasing a new version of Ultimaker Cura with the next generation slicing technology. Sure, it's revolutionary, but what does that mean? For Cura 5.0, we have built a new engine. It can slice finer and smaller part features, features that were impossible or very difficult to slice and print before. This means that what you thought was not possible in the past, well, they are now, including with the 3D printer that you already have. So now we can print finer part features. How fine? Think of injection molding. Injection molded parts have walls and other part features that are thin and small. This was a big challenge because depositing the material ended up causing broken walls. This example on the screen shows a 3D printed prototype of a casing of an Ultimaker printer printhead. We can now print it with Ultimaker Cura 5.0 and still maintain the level of detail. In the past, it was difficult to print this part with this level of detail. Even if you tweak a lot of settings, you will eventually hit limitations. But the printhead is not familiar to everyone. So to help demonstrate this better, I'm going to pull up an old friend. I have brought with me the Benchy. This is a standard-sized Benchy model that you can download for free online. I decided to use this model because everybody in the 3D printing world knows it. Benchy is also a very common 3D printing benchmark. It was originally designed to test the accuracy and capabilities of 3D printers. So I did a comparison with Cura 4.13, and this is what I saw. I used the default profile with a layer height of 0.1 and with an AA 0.25 print core. This is the smallest print core available for Ultimaker printers. With the default profile settings in Cura, it became impossible to print the Benchy completely, the smaller it gets. The gray, shadowy area shows that the walls are becoming too thin to slice. At 20%, it still looks okay. All the parts of the Benchy are intact. But at 15%, I have already lost my chimney and I no longer have a steering wheel because they will not be printed anymore. That's what the gray shadow means, that there will be no material deposited in these areas, and your print would fail. And at 10%, it's just a little hull and a little bit of roof. Not only in 4.13, but also in other slicers. You can try it for yourself. Then let's check with Cura 5.0. And with the same scales, this is what it looks like. I used the same default profile, same AA 0.25 print core, and even down to 10% scale, I can technically ride this boat, because everything is still in place. Here is a 10% Benchy next to a banana for scale, and here's the same 10% Benchy next to a Eurocoin, and it's so tiny, it's a Benchy for ants. So what is it that makes the engine capable of printing these finer details? We have completely rebuilt the slicing engine to introduce a new toolpath strategy. When you press the slice button in Cura, the engine uses all the settings you have in the profiles in order to calculate how, when, and where to deposit the material during printing. So far in Cura, this has been done with a fixed line width. The line width is based on the size of the nozzle, and it means that when printing, every single line is printed at the same fixed line width. For larger parts, this is totally fine, because the level of detail is larger than the actual line width. So the parts already look pretty great. But once you start to print smaller and thinner features, this becomes a problem. Take a look at this animation. It shows a preview of a print in Cura after slicing. This simulation of how this part of the model is going to be printed. The red line indicates the outer wall, the green line is for the inner wall, and the yellow is the skin. These smaller part features would be filled up in Cura with these fixed lines, and it tries to adjust as best as it can. But they aren't printing as good or as strong as they could be. Because for that to happen, these smaller part features need to be solid. Thus, we can only achieve this with smaller line widths, or if we can make the line width adjustable depending on the space that it needs to fill. Cura 5.0 slicing engine introduces a new toolpath strategy. A toolpath strategy is the way that Cura decides where and how to deposit the material. It uses what we call a variable line width strategy. Instead of having a line width that is constant, fixed, and rigid, Cura now decides and adjusts the lines according to the area where they need to be deposited. This adjustment is done by the slicing engine and optimizes the line width too, so all the lines in the area will fit better together. The end result guarantees a uniform fill of the part. Developing the Cura 5.0 engine, we figured out that the printers are perfectly capable of doing this. All we need to do is optimize Cura's already existing variable line width feature and make it smarter, even though the part feature is really small and thin. You'll actually see this better with a side-by-side comparison. You can see that in 5.0 the voids are properly filled up, and so it gives you an absolute best print result as possible. This way, parts become much closer to injection molded quality, giving better looking and stronger parts. Injection molded parts require walls that are quite thin. This was a big challenge to achieve with 3D printing in the past, because depositing the material ended up with broken walls, because the line width of the lines were strict and constant. Because of the new slicing engine capabilities, we were able to re-engineer the settings in our Ultimaker profiles to get the highest possible performance. So why is this a highlight? Why are we proud of this? Because greatness is a lot of small things done well. Do you remember what I said when I was talking about the toolpath strategy? I said that Cura uses all the settings in your profiles to create the file that your printer will use. When you slice a model, Cura takes into account all the machine, material, and quality profiles in order to create the print file. A print that performs great is not just because of the software or its slicing engine or the printer, but it's also because all the profiles that you use. So with the new 5.0 engine and its more efficient toolpath strategy and re-engineered Ultimaker profiles with higher performance settings on an Ultimaker printer, you can achieve faster printing times with Ultimaker 5.0. Of course, this will depend partly on the models that you're printing. To demonstrate this, here's a time-lapse footage of a test that we have done. You can see the difference in print times between Ultimaker Cura 5.0 and the previous version of the software. I also want to say that because of Ultimaker Cura 5.0, its new capabilities, we have unlocked applications we couldn't print before with FFF 3D printing. What was once impossible, we can now proudly say that we can do it now. And this has a number of practical applications, and we'll hear more about it soon. Like I mentioned, being able to 3D print finer details and thin walls unlocks more 3D printing applications for designer prototyping parts or for injection molding. Injection molded parts often have very thin walls, so these thinner walls are now easier to 3D print. You can see in this part how intricate parts of the design can be printed true to its design, ideal for all sorts of product development prototyping applications. And with the new capabilities of 5.0, we also unlock a new threshold for model making. Finer part features and thin walls are crucial for architecture. When designing for FFF printing, there are a lot of rules that you have to adhere to. such as the minimum thickness of your wall. But now that thinner parts can be printed with the new slicing technology, this means that we have reduced the limitations when you are designing for FFF and creating your 3D model in CAD. So, if you have tried 3D printing in the past and found yourself unable to achieve what you needed, this is an invite for you to look again. But don't just take my word for it. You're about to hear from several innovators who have already been trying out the new features. And better yet, after this event, you can download Ultimaker Cura 5.0 beta and try it yourself. There's a link to the Cura page of our website on the description below, and you'll find a link to some example models on the Ultimaker website when you download it. Finally, do you remember what I said, that greatness is several small things done really well? All of this would not have been possible without Tim Kuiper's research paper and the development of the variable line width technology, which is what Cura 5.0 is built on. And also the involvement of our community members, who helped us beta test the features. And finally, all the different teams in Ultimaker, who got us where we are and made all of this possible. Next up, we bring you the story of the team at the Tom Dixon studio, who were given access to an early version of Ultimaker Cura 5.0. Tom Dixon is an award-winning designer whose original style has led him to adopt innovative tools throughout his career. Established in London in 2002, his studio now employs over 100 people worldwide, who together create the design pioneering furniture, lighting, and accessories for a global market. Let's discover how they've benefited from Ultimaker Cura's digital manufacturing platform, including Ultimaker Cura 5.0.
My name is Tom Dixon, and I'm a designer based here in London, England, and I have a company here which is atypical compared to other product designers because we do our own product development, obviously the design, but also the distribution and the communication of all of our products as well. So this company is structured a bit more like a fashion company than a design studio, but we also have an interior design facility, and we have a restaurant here in our retail shop in the heart of London. 3D printing has been around obviously for a while now, and it was the talk of the design community for a long time. We'd see the early machines and their outputs coming through, particularly in design fairs like Milan. We preferred modelling by hand for a while until the scale of the machines became bigger and the precision became better as well. But it's proved a kind of invaluable tool for us on so many levels. I started designing really by making things with my own hands, and then moved into almost factory production, and then moved into, like every other design studio, mainly computer-based design. And I got more and more frustrated with the two-dimensionality of the digital world. So what was amazing when 3D printers came along was the fact that you could take those models out and make them physical models again. We use it on a wide variety of different tasks. We've used it for small batch production, so rapid manufacturing, as opposed to rapid prototyping. We've used it to make patterns for casting, for instance, so that we can actually use the plastic as patterns, whereas before you had to spend a lot of money getting very precise wooden patterns made. And we use it obviously for modelling full-size scale models or tiny models to explain to a customer or a factory what our intention is. But we're only starting to discover all of the possibilities, and we're going to start, now that we've got the machines here in the studio, also using them for making things like stamps for ceramics, back stamps, or for even printing paper bags and things like that. So we're going to use them to actually make tools to do other things as well. We'd like to use Ultimaker because it's a very generic software that a lot of people know how to use. It's user-friendly, but also the machines are relatively affordable, and we're able to get moving very quickly. You don't need huge amounts of skilled expertise. And of course, because they're widely distributed, you can get the spare parts and you can get the filaments as well relatively easily, right? So there's something about being with a company that's got wide distribution and recognition that makes it easier for us to use the Ultimaker. Yeah, I mean, there's some pretty simple things that are much better now with the new software, specifically thin walls and things that seem pretty basic, but these really sharp points were previously impossible. So it's kind of nice to be able to move one step further towards making really precise, dimensionally precise objects, which we can actually use even in small batch production as components for lamps or other parts, right? So we've outputted for the community a chess set, and we've been able to really try and make some components. It's a kind of demonstration set, but also with a practical outcome of all of the different possibilities of the new software. Okay, so I think we're seeing really the very beginning. I mean, this technology seems quite mature now, but we're only seeing the beginning of the revolution in not so much rapid prototyping, but obviously rapid manufacturing. And as we become more and more able to print, for instance, metal at low cost or eco materials, which is increasingly a really strong need and narrative. We're going to be using these more and more for actual final products rather than prototyping. And also for things like unique pieces. So, now, particularly with NFTs, there's a lot of demand for algorithmic design, so each one different. There's a lot of demand for custom objects as well, for people that don't want what everybody else has got. And also tailor-made for specific needs. So I think we're going to be using it more and more. And of course, this is going to become really the manufacturing technology for the 21st century. Okay, thanks for watching our adventures in 3D manufacturing. I'm hoping to be even more part of this digital manufacturing revolution. Goodbye.
Now it's time to put Ultimaker Cura 5.0 to the test. Steve Cox is a qualified professional engineer with over 30 years of experience in working in the automotive industry, and now a 3D printing technologies consultant for a range of sectors. We gave Steve early access to Cura 5.0 to test its features and see if it can overcome some of the challenges he has been encountering with 3D printing in the past.
Hi, I'm Steve Cox. I have my own company called M4E Consulting. My background is I worked as a professional mechanical engineer in the automotive industry for more than 30 years. But for the last 8 years, I've been involved with 3D printing and additive manufacturing. I spend time developing applications, showcasing methods of 3D printing, and helping clients adopt this technology. And one of the things I enjoy the most is exploring what this technology can do and how people can use it. Ultimaker and the Ultimaker 2 that I bought 8 years ago really started me out on what I've heard called a walk in the woods with additive manufacturing and 3D printing. It still ranks as one of the best decisions I've ever made because it works straight out of the box and it allowed me to concentrate completely on applications rather than just making the technology work. In whatever I do, I'm always striving to achieve the best possible quality output, and I'm sure many of you are the same. But those attributes of quality always stood me in good stead. So how do you create the best possible quality with the highest level of efficiency and the minimal amount of waste? It's something that I'm always keen to explore in the work that I do with 3D printing because I'm always wanting to present the best possible way of 3D printing to the clients that I work with. So that lean manufacturing mindset completely frames what I do now. I spend a lot of time when I'm designing and setting up 3D prints, and that often means spending time in the preview side of the slicing software to ensure that I know what kind of output I'm going to get and it's going to achieve the quality that I'm looking for. Thin walls and small features can often be challenging when striving for that kind of quality and efficiency in 3D printing. And sometimes the requirements of 3D printing can bear too heavily on the design. What do I mean by that? Well, maybe you're prototyping using 3D printing for a different method of manufacture. And the design requirements should be driven by the ultimate method that you're going to use to produce that part, not by the 3D printing side of things. Take as an example this design, which I've created using Autodesk's Fusion 360. and the new plastic design tools that they've just introduced into that software to make designing of injection molded parts more efficient. And those injection molded parts are the kind of thing that often use thin walls, clipping features and webs. In this example, the parts were designed around the rules for a 1.5mm injection molded plastic housing. That 1.5mm wall thickness for these parts presents some issues when it comes to 3D printing. 1.5mm isn't an exact multiple of a 0.4mm nozzle, if that's what you're using. It's also not an exact multiple of a 0.6 or a 0.8mm nozzle either. But those inefficiencies are dealt with by Cura5. In Cura5, the introduction of variable line thickness deals with those inefficiencies of creating that 1.5mm wall thickness. That's done automatically by the software, and no user input is required to create those variable line widths. So let's take a look at that 1.5mm wall thickness. In the preview of the slice in previous versions of Cura, you can see that that 1.5mm wall is created from 2 outer shells, 2 inner walls, and a very thin line of infill. And in the corners of the part, some very small amounts of infill applied. Is that really efficient? Is that really the best quality? Is that really going to give you the best possible 3D print? Now let's compare that with the same part sliced with Cura5. That same wall thickness now is being created by 2 very even outer shell lines and 2 very even inner wall lines. No thin infill, no messy condition in the corners. That has to be much more efficient because we're talking there now about using 4 toolpaths instead of at least 5 in previous versions of Cura. It's a similar story when we look at these small clip features that are holding the 2 parts of the housings together. Again, let's look at it in previous Cura. You can see that the clip is being created by an outer wall, an inner wall, and again, a small squirt of infill in the middle of the clip. Let's compare that to Cura5. In Cura5, you can see those same clip features being produced by using 1 single outer shell line and 1 single inner wall line. Again, those clips are now being created in a much more efficient manner. There's an overlap condition that I've created in this design that you can see in this image between the upper and lower case halves. With this overlap, there's a 0.25mm gap between the 2 overlap conditions to ensure there's no interference when the 2 case halves are brought together. That means that we end up with a very design-driven dimension of 0.625mm for these overlap wall thicknesses. So let's take a look how previous versions of Cura deal with that 0.625mm wall thickness. You can see here it's doing it by creating 2 very uneven shell lines. Let's contrast that to Cura5, where you can see that same wall thickness is being generated using a single shell line. That's 1 toolpath instead of the 2 toolpaths required in previous levels of Cura. The upper case half has web features designed into it, which are typical of injection molded parts of this type to increase the stiffness of an open design such as this. In this case, those web features are 0.75mm wide. And that's a rule that's driven by the injection molding side of things, where you need a web thickness of half the main wall thickness to ensure that you don't get any visible sink marks on the outer surface of the part. So you can see here the previous levels of Cura create those webs using 2 uneven shell lines, and also there's some non-uniform infill lines going on that you can see in this preview image. Let's contrast that to Cura5, where those webs are created using 2 even shell lines. Again, massively improving the efficiency of the 3D printing and also hopefully the quality. All of these improvements contribute to a better, cleaner, higher quality 3D print. The efficiencies in toolpathing created by variable line width control bring about a significant reduction in 3D printing time. In this example, the print time using Cura5 for the lower casing was 17% less than when the same part was sliced using Cura 4.13. And for the upper casing, the print time reduction was 15%. That's a really beneficial time improvement, and one that really fits well with my desire to create the most efficient 3D printing experience with the highest possible quality. Oh, remember that 0.625mm wall thickness? How did that turn out? Well, let's take a look. That's pretty impressive. And that's the kind of quality that I'm looking for in the output from my 3D prints. So all of the things that we've seen in this presentation show how Cura 5 contributes to better quality printing with higher efficiency. That for me is a perfect combination. And the great thing about Cura 5 is that it does this for everyone, not just for those people using Ultimaker machines. So you can see here that these parts were produced on an Ultimaker 3 that's 5 years old. Not the latest S5, not the latest S3. And that shows that Cura 5 delivers excellent results no matter what the age of your machine. I hope that's given you a really interesting insight into what you can expect from this very latest, exciting version of Ultimaker Cura. Thanks for listening. Enjoy the rest of this showcase.
As we saw earlier, the ability to print finer details with Ultimaker Cura 5.0 is especially useful for architects who need to create stunning models with intricate features. Now, we're delighted to introduce Carlos Castillo, an architectural designer, fabricator, and educator. He is part-time faculty at Parsons School of Designs at the New School in New York, and previously worked at Bjarke Ingles Group, where he guided dozens of design teams in the fabrication of thousands of models in their first 3D print farm. Let's hear more about Ultimaker Cura's architectural potential from Carlos.
So I'm Carlos Castillo, currently a professor at Parsons New School. Becoming a fabricator for me wasn't necessarily planned, but it was always a part of my life. My dad and I would build a lot of things. I kind of fell back in love with fabrication once I went to architecture school. From the beginning, the idea of 3D printing and just having something come out of nothing up to this day really fascinates me. I started working for Tristan Al-Haddad right out of school. He's a professor of architecture and a sculptor back in Atlanta. I moved on to New York. I got the opportunity to work for Raphael Vinoli. Very traditional, a lot of hand techniques. From there, I moved on to working for Bjarke Ingles. Bjarke Ingles Group, or BIG as most people know it. Models for them are very important. Every single idea needs to be accompanied with a model. If not, it's not valid. I helped develop their first 3D print farm. Started with 2 Ultimaker printers, and after like 2 years, we ended up with 11 machines. I started working at the New School and sort of take all of that accumulated knowledge. I'm now trying to teach my students to use technologies in their advantage. Models validate designers' ideas in a much more convincing way. One of the things that we're able to do now is to capture a lot of small details in even smaller scales. Cura 5.0 has allowed us to capture way more resolution. Being able to produce very thin walls, it increases the speed of output. What I appreciate the most about the UI of Cura is their preview, where I can really understand how the material is being deposited. One thing that I've enjoyed a lot is the lighting infill feature. It saves a lot of material. The Architopology project is a collaboration between myself and Ultimaker. We're producing a bunch of different towers. You'll be able to download and be able to slice and modify architectural models from this imaginary project. Keep following Ultimaker. We will make an announcement fairly soon.
And here you have it, a metal part sliced with the new Ultimaker Cura 5, print it on an Ultimaker and post-process into a final metal part. Hi everyone, my name is Marit Hofmans. I'm a product marketeer at Ultimaker, and in the next couple of minutes I would like to talk to you about metal FFF 3D printing. For those of you familiar with metal printing, you may know that printing metal parts with Cura and an Ultimaker printer is already possible. However, with the release of the new Ultimaker Cura5.0, we take a big step forward in making metal FFF printing easier and more successful. This means that you can create high-performance parts with the advanced properties that metal has, such as an extremely high strength or temperature resistance, allowing you to print applications that are often not possible in using plastics. So, how do we achieve this with Cura 5? As explained earlier by Mariska, the new Cura 5 comes with big improvements for creating detailed and thin parts. This is not only relevant for plastic parts, also metal applications will greatly benefit from this. With the new Cura improvements, metal parts with thin walls will benefit from an increased wall stability. This is very important for these parts because it will help to minimize the chance of delamination during the post-processing steps, and thus it will contribute to a successful end result. But next to the general Cura 5 improvements that metal parts will benefit from, we're adding more. We will introduce specific features and settings for metal printing that Ultimaker users that print with BASF Forward AM UltraFuse 74pH and 316L metal filaments will directly benefit from. These new features will make the slicing workflow for metal printing easier and give you more control over the outcome. So, what are these new features exactly and how do they improve the printing of metal parts? For this, we will move to our experts, who both have been involved a lot in metal FFF 3D printing. Welcome.
Sure, Marit. Thanks for the introduction. My name is Andrea, and I'm part of the product management team and leading the metal printing initiatives within Ultimaker. Here with me today is Tobias.
Hello, my name is Tobias. I'm the business development manager for our UltraFuse metal filaments working for BASF Forward AM.
No doubt that producing metal parts by standard FFF technology is coming out strong as a high interest topic from the 3D printing adopters globally. For those that are still not familiar with the process, extrusion-based metal printing rely on the processing of highly filled metal filaments, like the ones offered by BASF Forward AM, to produce a green part that is subsequently debinded and sintered to finally obtain a near net shape and full metal part. The sweet spot for this technology are the thousands and thousands of customized tools, manufacturing aids, and obsolete non-critical components. When operating the technology within this sweet spot, user can potentially realize cost savings up to 90%, lead time reduction up to 70% for small series. However, metal FFF on open systems like Ultimaker is still in its initial stage of development, and more is needed to reach the level of readiness to fully enable a flawless and reliable metal parts printing process. The path towards the needed level of process performance and quality involves development on all fronts: hardware capabilities, material, but also software capabilities. And here today I'm really in particular referring to the print job preparation by means of a slicing software like Cura. Many of the benefits that the introduction of the new engine in Cura 5.0 are definitely applicable when dealing with printing metal parts. Being able to print sharp corners and stable thin walls or features are the major area where the development of the Cura engine was focused on in response to some of the major blockers that we have identified while developing customer application. So, Tobias, what is Cura 5.0 bringing once you are developing application with customers?
Thank you, Andrea, for giving me the opportunity to talk about our use cases. So with the new CC 0.4 millimeter print core, for us it was a natural step for new features and a new way to print thin walls. Thin feature can suffer from void and small gaps, which reduces the stability and integrity of the specific area. Not only in the debinding and sintering process, also in the final metal part, these defects would still be there and could lead to an undesired failure during the application. So printing small details is a very well-known and good application for 3D printing and is now more accessible with better performance. For example, vertical or horizontal holes and of course labeling of parts.
Another source of inaccuracies and part failures was identified by customers when having actually to modify the dimension of the part that they were about to print in order to accommodate the shrinkage of the part during the binding and sintering. Tobias, can you explain why you need to control the part scaling prior to starting the print, and why it's so convenient actually to have it in Cura 5.0 and it's already done automatically?
Let me explain this to you. The new automatically scaling of the parts in Cura 5.0 is an important step towards the reduction of complexity along the process chain. I know it seems to be mysterious for quite a lot of people, but I can tell you it's not scaling. The part prior to printing is not witchcraft. During the sintering process, the metal powder starts to solidify by diffusional processes. The empty areas of the former binder vanish and the volume contracts, leading to a shrinkage. To compensate for this volumetric contraction, the parts need to be scaled prior printing. This corresponds to 119% in X and Y and 125% in the Z direction. Besides the filament composition, which is critical for the shrinkage, also the part geometry can have an influence on the accuracy. Nevertheless, sintering technologies are always referred as near net shape, and an automatic scaling function will help customers dramatically to overcome the first hurdle when starting to print metal parts.
Well, thanks, Tobias. Another milestone towards the development of the Cura 5.0 engine capabilities was achieved when Ultimaker and BSF Forward AM started a joint application development with Liber components. In the framework of the collaboration, one category of application that was identified as a target for being produced by Metal FFF were the customized assembly tools, like this one that you can see here. This is a part that fits within the 10 to 12 centimeter size, is a non-standard off-the-shelf part with the need for tolerances within 0.3, 0.4 millimeter over the whole part, and a limited amount of units that needs to be produced per year. Metal FFF was therefore selected as the manufacturing technology to do this cost out, but also to reduce lead time and the whole logistic around the sourcing of this part. Indeed, designing tricky assembly tools requires many efforts and time with conventional manufacturing methods. One of the major challenges that this part was featuring with the former engine version we were using in the past was the fact that the part was showing distortion along some of the thin and high height over width areas after sintering. Tobias, from a processing perspective, which is the origin of the distortion that we have seen in this application?
So, as far as I could understand it, it's based on the crystalline character of our binder, which introduces internal stress along the thermal history of the printed lines in the part, which could also be seen in the phenomena like warpage. In the green state, these stresses are stored, but the matrix resists to the deformation. So during the debinding steps, the matrix is removed and is getting weaker, and the part starts to distort, and the shape is transferred into a full metal part.
So actually, by understanding, therefore, the origin of this distortion, BSF Forward AM and Ultimaker R&D identified in the introduction of the alternate wall directions feature in the Cura slicer a solution to remove part distortions during the sintering process. This feature is now present and used as default settings in the new Cura 5.0 when using both UltraFuse 174pH and 316L print profile, giving its key role and the high number of parts and design that requires the alternated wall direction use during print job preparation. As a proof that this new feature is relevant for a broad number of parts, Tobias brought a part today that relates very well with the challenges that we were describing before. Tobias, what is the story behind this part?
This part comes from our very first customer journey, where we did not succeed to meet the desired tolerances, even we did everything right from the state of the art at that time. As you can see, we have high and thin walls, and in the sintered state, it's distorted. As you might remember, you gave us the opportunity to test the feature of alternating wall directions, and it worked on the first print. Since that, we knew it is a mandatory way of printing, which is needed for our material and post-processing.
To conclude, what we have shown today is the beginning of Ultimaker journey into the field of meta printing. As you can see, we are strongly engaged with our ecosystem partners and representing BSF World, I'm here today, thanks to Bias. And we will extend further the capabilities of our Cura engine and hardware to enable users to extend even more the range of metal parts and get an even higher control from printing step to the final sintering step.
Thank you, Andrea and Tobias, for all these interesting insights. So, to summarize, this means that with the new automatic scaling and alternate wall directions feature in Ultimaker Cura 5.0, we will make metal FFF printing easier and more successful. And, as Andrea already mentioned, this is just the start. We are happy to announce that we are working on an exciting new metal 3D printing solution that will use Ultimaker and Cura to unlock more industrial applications. We will reveal more details about this in the upcoming weeks and months. If you're interested and want to be the first one to hear more about this, then please go to ultimaker.com/metal and register yourself for updates. Now it's back to Jürgen for some final remarks.
I hope you enjoyed the showcase and are inspired by Cura 5.0 and our new metal package. One cool aspect of leading a high-tech company is to learn how people are using our solutions to their benefit, especially in ways that we didn't even think of during development. It's really about empowering people. I look forward to seeing a whole new range of 3D printing uses and applications in new verticals emerge because of the hard work by the Ultimaker team and our incredible user community. I do want to thank Tobias Rödelmeier, Tom Dixon, Steve Cox, and Carlos Castillo, the team at Ultimaker presenters, as well as the showcase team. Well done, everybody. Thank you, everybody, for your attention, and see you at our next showcase event in the fall of 2022.